Hello, you are welcome to today's class. Today we are considering arithmetic progression and our sequence and series. So, what is arithmetic progression all about? Because today we want to be able to prove the formula that can be used to add up any number of terms in a series of numbers or in a sequence of numbers. So, how do we prove that formula? And after that, we're also going to learn we're also going to prove a formula that can be used to obtain the value of every single term. So there are some conventions we need to take note of before we can do all of that. So arithmetic progression basically deals with difference between numbers. Okay? So whenever you have several numbers, maybe 2, 4, 6, 8, 10, 12, 40, there's always a relationship between the numbers. So when you look at this, you see that whenever you subtract 2 from 4, the answer you get is 2. When you subtract 2 from 6, you get 2. When you subtract 10 from 12, you get 2. So when it happens like this, there's a relationship between the numbers. And when the difference between the numbers are the same like this, you say they form an arithmetic progression. So arithmetic progression deals with differences between the numbers. There's also another one called geometric progression. But for the geometric, if you have maybe something like 2, we have 4, here will be 8, here will be 16, here will be 32, 64. So for geometric progression, we rather deal with the ratio between the numbers. So here when we find the answer for 4 over 2, you see that it will be the same as 8 over 4, it will be the same as 16 over 8. So, and all of that will keep giving you 2. So for arithmetic, we deal with differences, and then for geometric, we deal with the ratio. But today, we are going to look at arithmetic progression. So in sequence and series, we will always have several numbers in a row, okay? Now, we always call the first number, that's the first number you see, or the other word we use for the first number is the first 10. We always call it A, okay? So to get the next number after the first 10, we'll add the difference, A plus D. So D is the difference here. The same way as we have 2, 4, 6, 8. And then to get 4, you need to add the difference between 2 and 4, that is 2. To get 6, you need to add 2 to 4. So here, to get this 10, we have to add the difference, A plus D to A. Now, to get the next term after A plus D, we have to add another D to this D. So the D will now become 2. So we have A plus 2D. To get the next term, we have A plus 3D. The next term will be A plus 4D. And then it will keep going like that. Okay, good. Now, what is going to happen is that we call this number the first term. The first term. We call this the second term. We call this the third term. We call this the fourth term. We call this the fifth term. So this is how it is. So first, second, third, fourth, fifth term. Now you realize that we want to be able to prove a single formula that can be used to obtain any term here. That's what we are about to do. Okay. So you realize that if we have 2 at this side, or for the second term, the coefficient of D is 1. You've seen that. For the third term, the coefficient of D is 2. For the fourth term, the coefficient of D is 3. For the fifth term, the coefficient of D is 4. When we say coefficient, we mean the number that is multiplying D is 4. So we can see that they always subtract 1 from the 10. Okay, they subtract 1 from the 10, then you get the coefficient of the D. You subtract 1 from 4, you get 3. You subtract 1 from 3, you get 2. So in order to produce a single formula that can be used to obtain any term, what we'll also do is that we'll do the same thing. There's always been an A. We have A here, A here, A here, A here, A here. So we'll also repeat our A. A plus. Now, the 5, 4, 3, 2, 1. Ours, let's call it N to represent the 10. Okay? To represent a particular 10. That's the N. So to get the coefficient of D, as they subtract 1 from the 10, we'll also subtract 1 from N. And they'll multiply that by D. Okay, now you see that what we have is the last 10, right? This is the last number on these numbers, on these several numbers. So we say then the last 10, the formula for the last 10 can be written as a plus n minus 1 times b. But then this formula, which can also be used to obtain a single 10, any particular 10. So another way we can also write it is that un equal a plus n minus 1 times b, where un is the value of a particular term, or it's just one term. Okay, good. So you see that over here, if maybe you want to get the fourth term, for the fourth term, don't forget n is equal to the 10, or the number of terms. Okay, good. So for the fourth term, you write u5, you replace the n with 5, you have a plus n minus 1 will become 5 minus 1 times b. And 5 minus 1 is 4, so you get a plus 4b. And that is the same one we have here, a plus 4b, right? Good. So we've been able to prove a single formula that can be used to obtain the value of any term at all. Now, the next formula we want to be able to prove is, we want to sum all these numbers up, we want to add the numbers up. We want to get a single formula that we can use to add all the numbers, okay? So that way, maybe you have several numbers and then they ask you that you should find the sum of those numbers. You just have one formula, you can use that one formula to add all the numbers. So that's what we are about to do. So in order to do that, what we'll do is that we'll replace all the comments here, we'll replace that with an addition sign, meaning we are adding them. So let's add them up. So this plus that, plus this plus that. So let me stop here. So plus, good. So we have our first term plus second term plus third term. So let's say when we add them up, the answer we are going to get, let's call that answer as Sn. Okay, good. Plus, now we have L minus 2D. My marker is trying to mess up. So we have L minus 2D, we have L minus D, and then plus L. So the L is the last number, the last term. So to get a term before the last term, we subtract D from L to get this term. In other words, if we add D to L minus D, you are going to get L, right? Good. Now, what we will now have to do is that, you see, if you have something like 1 plus 2 plus 3, the answer is not different from 3 plus 2 plus 1, right? The answer is the same as that. So now we want to also reverse the whole thing. So we start writing it, but we start from this side. Okay, when we start from that side, we get L plus L minus D plus L minus 2D plus A plus 2D, A plus D, and then plus A. Now, let's add this and that. So A plus L gives us A plus L. Now, A plus D plus L minus D will give us A plus L because this D cancels out to the D here, right? Good. So we get A plus D here. A plus 2D plus L minus 2D will also give us another A plus L. Plus, here will also be A plus L, A plus L, plus A plus L. Now, the answer will still be Sn, right? If you add 1 to 3 to 1 to 2 to 3, and then you reverse it and you rather add 3 to 2 to 1, the answers are still the same. So the answer wouldn't change from Sn. Okay, good. But since we added this to that, we also have to add Sn to Sn. And Sn plus Sn will give us 2Sn. Okay, we are going to get 2Sn for that. Now, how many A plus L's do we have here? We don't know the number of A plus L's. We only know that they are A plus L's, right? So, what we'll do is that, my marker is really disturbing me today. If we have something like 2 plus 2 plus 2 plus 2, the answer is 8, right? Another way to get 8 is just counting the number of 2's here. And the 2's here are 4. So 4, then multiply by just one of the 2, you still get 8, right? Good. So what we'll do is that, since we don't know the number of A plus L's here, And the reason why we don't know the number of a plus else here is because of this space. This space tells us that there are so many of them, but we don't know their value. So we say that, okay, then let's let the number of a plus else here be n. Okay, so let's let the number of a plus else here be n. So what we are just going to do is that we'll multiply n, which is the number of a plus else there, by a plus l. Now that will be equal to 2Sn. Now we want to make the sum the subject. So we make Sn the subject. So Sn will give us n over 2, then a plus l. Okay, but from the formula we proved before this one, we know that the value of a plus l, right? We know that a plus l, but l, this l, we prove that l is equal to a plus n minus 1 times b. So we'll come and fix the l here. Okay, so this a will add to this a to give us 2a plus n minus 1 times b. So this is the formula, either this or that. These are the two formulas that we can use to add numbers in arithmetic progression. Okay, so we use the first one when you know the last number or the last 10, then you fix it here. But if you don't know the last 10, then you have to use this formula. So we wouldn't solve questions here because time has been spent. But then in other videos, we will solve questions using this formula that we have just proved. Okay, so let's define the variables we have here. So the a is our first 10. Okay, and then the n is the number of tens. The Sn is the sum of n number of tens, of n tens. Meaning that if you want to add maybe 6 different numbers, then the n will be equal to 6, okay? Good. So here we are adding n different numbers, so we fix n there. And what is left? You have the l. The l is equal to the last 10. And then the d is equal to the difference. The d is equal to the difference. My board is already full. Okay, so there's one last thing I want to talk about, how we get the d. So in sequence and series, we call the first term u1, second term u2, third term u3. Okay, that's how we do it. So in order to get our d, let me just use this small space for that. In order to get our d, we subtract u1 from u2. So d is equal to u2 minus u1. Or we can subtract u2 from u3. So that's how we get it. You subtract this from that, or this from that, and then you always get d. So from here you see that if you subtract a from a minus a plus d, we get d. Right? So that is how we prove the formula under arithmetic progression. In subsequent videos, we also prove the formula for geometric progression. And we have so many questions that we'll be solving on sequence and series. So just stay tuned. This is not difficult. Believe you can do it. I know you can do it. So never doubt yourself. I know you can do it. You're a great person. Okay. I was reading this quote somewhere on Facebook, and then it went like, you have to believe you can do something, although you know you can't do it, but you have to believe it. And then you work towards it, and it's going to be possible. So all the best to you. It's not difficult. Just look at it carefully. Try doing intensive study on this, and you understand it. Okay, so all the best to you, and bye-bye. Have a good day.